Is screen visible? Okay. So we have completed the topic of digital data and digital signal conversion. In that we have studied that a bit can be represented by a voltage level. Depending upon the voltage level crosses the x-axis or not, we can divide them into various categories. These schemes are called as the line coding schemes, which has non-return to zero, in which signal does not crosses the x-axis. Non-return to zero inverted level. Depending upon the level, the voltage will take the information of a bit. Inversion, if the capability of inversion or lack of inversion occurs, then a voltage level will represent a certain bit. Then we have Manchester, differential Manchester, B8ZS, HDB3. The last two are for the case when we have a long sequence of zeros and ones. These may cause problem. And to avoid such problems, continuous zeros are substituted by the HDB3 or B8ZS coding schemes. The next coding scheme is the digital data and analog signal. So in this we will study how a digital data is encoded in the form of a sine wave or cosine wave or other waves also. It is similar to our first unit amplitude modulation technique. Here also we know that there are three characteristics of a sine wave, and these are amplitude, frequency, and phase. So accordingly, if we change any one of them, we will call that scheme as amplitude shift keying, frequency shift keying, and phase shift keying. The block diagram of a digital to analog conversion scheme is, it should have a digital data sequence, a long sequence, a repetitive sequence of zeros and ones, consecutive zeros and ones. These all are the digital data, and they are sent or passed through a modulator. Modulator is simply an electronic device which will convert these data in the form of voltage or current levels. Then after modulator we will have a analog signal, and this analog signal has three characteristics: amplitude, phase, or frequency. So accordingly we can vary, let us call amplitude by capital A, frequency by capital F, and phase by capital T. So we can vary any of them, and accordingly that type of coding scheme will be called, if amplitude variation, it is called as ASK. If frequency is varying, it is called as FSK. If phase is varying, it is called as PSK. Now after the transmission, the receiver will receive the analog signal, and again demodulator is an electronic device which will convert the energy of one form into another form. That is, analog signal is converted into the digital signal. So we can divide the digital data to analog signal conversion technique into three parts: ASK, amplitude shift keying; FSK, frequency shift keying; PSK, phase shift keying. And these three techniques are not quite useful nowadays. In fact, their modified version, that is quadrature amplitude modulation, is more relevant today. So it is of more use, as compared to single ASK, single FSK and single PSK. Single means we only vary the amplitude or the frequency or the phase. In case of quadrature amplitude modulation technique, we combine the amplitude and phase. Both are varied simultaneously, and it is more relevant as compared to the previous three techniques. Now, some aspects or some characteristics of a digital to analog conversion methodology. The definition of bit rate and baud rate will remain the same. Bit rate is number of bits per second which are passing. Baud rate, the number of signal elements which are passing per second. And the analogy of vehicle and passenger also remains same here. It is R, small r, which will represent the vehicle and passenger analogy. And according to that analogy, what we want is maximum number of passengers to be transferred on least number of vehicles. So vehicles are our signal elements and passengers are our data elements. So to have an efficient use of the coding scheme, we should have as much as signals can be transferred, as much as bit can be transferred on least number of signals. If one element or one voltage level carries one signal, then R is equal to 1. If R is equal to 2, then 2 signals are carried by one element. If R is equal to 3, 3 bits are carried by one signal element. If R is equal to 4, 4 bits are carried by one signal element. So our main purpose is to achieve vehicle and passenger analogy and to have maximum passenger on single vehicle to avoid congestion, to avoid traffic jams. So that's why we want more data rate with less number of signal elements. The definition of data rate versus signal element is same and their relationship is also same. N is the data rate per second, BPS, that is bit per second. R is the value of number of bits per cycle per signal, and for analog signal it is given by R is equal to log to the base 2 capital L. Capital L is the number of different signal elements. So we can say bit rate is simply the same as discussed in digital and data, digital signal technologies or coding schemes. Bit per second we have used there. So same definition of bit rate is used here also in digital to analog conversion. Baud rate is the number of signal elements per second. So that definition is also remains same in digital to analog conversion. In the analog conversion transmission of digital data, the baud rate is generally less than or equal to the bit rate. Okay, the vehicle and the passenger analogy remain the same in digital to analog conversion as well. Bandwidth. The required bandwidth for the analog transmission of digital data is proportional to the signal rate except for frequency shift keying, in which the difference between the carrier signals needs to be added. So the difference in the formula for bandwidth will occur in case of FSK. For ASK, PSK, it will remain same. Carrier signal, as the name suggests, it must be a sine wave. It must be a high frequency wave. Why the frequency should be high? We have discussed it in the first unit. Why the frequency of carrier should be high? Can anybody answer?
सर ताकि ये मोर डिस्टेंस ट्रेवल कर सके.
Why it will travel more distance if it has high frequency?
क्योंकि सर ये जो सिग्नल होता है अगर हाई में रहेगा तभी तो एम्पलीफाई होगा और ज्यादा.
नहीं, इसका मतलब ये है कि frequency is directly related with your energy. Energy will be more if frequency is more. So if the signal has more energy, then it is capable of traveling larger distances. Okay.
Yes, sir.
So as already discussed in first unit, the carrier signal must have a high frequency so that we can send the signal to larger distances. This base signal which will act as a carrier will result into superposition of modulating signal. So here we will again make use of the old terminologies of first unit. We have a modulating signal. The modulating signal is our bit stream, because here we are talking about digital data to analog signal. Means our modulating signal will be the different voltage levels which will represent a stream of zeros and ones, that is bits. Then we have a high frequency carrier wave carrier signal. Then we will superimpose the message signal or modulating signal on the carrier. And in the end, there will be change in the characteristic properties of the carrier. And what are the characteristic properties of carrier? These are amplitude, phase, and frequency. So this method of changing or modifying one of the characteristics of the carrier wave is called as shift keying. Means we are shifting one of the key properties of sine wave, cosine wave, or another type of waves. So due to this variation in key properties, characteristic properties of sine wave, we call this method as shift keying. Now the first topic in shift keying is amplitude shift keying. In amplitude shift keying, as the name suggests, the variation in the amplitude will be there, provided that both other two characteristic properties should remain constant and only the amplitude should be changed. It is called as binary ASK, BASK. Why binary ASK? Because it will represent the stream of bits, that is zeros and ones, by two type of amplitudes. You can see in front of you your screen that we have a bit stream which is 10, 11, 0. So according to amplitude shift keying, these bits should be represented by the voltage levels. And as the voltage levels are only 2, that's why it is called as binary amplitude shift keying. Why it is called as shift keying? Because it is changing one of the key properties of the characteristics of signal, that is sine wave or so. So you can see here first, can you see the cursor? Can you see the cursor moving on the screen?
Yes, sir.
Okay. So if you see at this first signal, it is 1. So it is represented by amplitude, constant amplitude for 1 of sine wave. The next signal element is a 0, which is represented by a 0 amplitude. Next we have 1, which is again represented by amplitude. Again we have a 1 which is again represented by a constant amplitude. Then we have a 0 which is represented by a 0 amplitude. So you can see here in amplitude shift keying, the binary ASK, binary ASK means we have two bits, zeros and ones. These are represented by only two levels. That is, there will be a constant amplitude or there will be no amplitude. So that's why the name binary ASK. And it is also called as on or off keying OOK. On off means for 0 there is 0 amplitude, for 1 it is a constant amplitude, on amplitude. However, the binary ASK is of not much use. In fact, the multi-level ASK is of good use. So, with respect to two levels in ASK, we can also have a 4-level ASK, 8-level ASK, or a 16-level ASK. These are called as multi-level ASKs, and multi-level ASKs are of more use as compared to binary ASK. If we look at the bandwidth diagram, the bandwidth is centered around the carrier frequency. R is equal to 1 means one signal element will carry only one bit. So if you see at the diagram, this one complete signal element has 3 crest and 3 turf. If you see next one, it also has 3 crest and 3 turf. Similarly, for the third bit one, it has 3 crest and 3 turf. So one signal element will carry one bit, that is R is equal to 1. Bandwidth is given by 1 plus D into S. D is a factor which vary from 0 to 1. So from here we can conclude that bandwidth will be minimum S and maximum 2S. So bandwidth will be 1 plus D into S. D can have two values, 0 and 1. So on substituting minimum and maximum value, the bandwidth come out to be S and 2S. Now how to implement the binary ASK? To implement the binary ASK, we require a NRZ signal, that is non-return to 0 signal. And in NRZ signal, you know, we have x-axis and the voltage level does not cross this x-axis. So we have a NRZ signal that represents high voltage as 1, low voltage as 0, high voltage as 1, high voltage as 1, and 0 voltage as low voltage, and voltage does not cross the x-axis. Then we have a carrier signal, and let us call it as a message signal M. Let us call this as a carrier signal, and let us call the after superposition this as a modulating signal. So in modulating signal, when this bit stream or modulating signal is superimposed upon the carrier, then there will be change in the characteristic properties of the carrier, and that is amplitude. So one signal element will represent a 1 bit high, 0 voltage will represent a 0 bit, next consecutive bits 1 1, signal elements will represent a bit 1, and this signal element 0 will represent a bit 0. Now how to implement with the help of a block diagram? In a block diagram, we require a message signal represented by M, a oscillator which will produce a carrier frequency, and this multiplier will multiply or superimpose the modulating signal on the carrier, and we get a modulated wave. And modulated wave have consecutive voltage signals and the voltage signals having 0 amplitude. So Arrow marks represent the zero amplitude. So in binary ASK, the bit streams are represented by two levels of signal. R is equal to 1 means one signal element for one bit, and block diagram has three parts: modulating signal, carrier produced by oscillator, multiplier will superimpose modulating signal on carrier. We obtain a modulated wave. Modulated wave has only two levels: amplitude. One for high signal is represented by some amplitude, and low signal is represented by a zero voltage. And the input signal for amplitude shift